Hello, welcome to this video demo on ShopJob T3. You should have reviewed the paralleling operation PowerPoint for this lesson before trying to do the ShopJob. Part 1 here, we're just going to reiterate that to phase out a transformer that has a 1-to-1 ratio properly, you should connect it to a low voltage power source to determine what is the primary or the secondary coil. Keep in mind the secondary side will have compensating windings by design, and the voltage from the low voltage power source will appear to be slightly higher on the secondary side as opposed to the primary. For this shop job, the voltage rating and the transformer kVA rating is as follows. We have a 120/240 on the primary and a 120/240 on the secondary. The transformer is rated at 0.250 or 0.25 kVA at 60 Hertz. For the first portion, where you're going to have no load connected, the voltage readings are as follows. You should see 120 volts applied from line 1. You will be going to H1 and H3. That's a parallel connection. On the neutral side, you'll be going to X2, X4. That is also a parallel connection. Each coil on the primary side will experience 120 volts AC. At a 1-to-1 ratio, the load side will read 120 or higher due to the compensating windings. So we will read that out of the X2, X4 connection and the X1, X3 connection with our digital multimeter. On the secondary side of a transformer, when you have a single phase transformer, it's also often referred to as X1 and X2. This right now can be referred to as an isolation transformer or a control transformer as well. At rated load for the second voltage reading of this shop job, we'll have the transformer loaded up with 125 lamps. 2 lamps at 125 watts apiece will give us approximately 250 watts of power being drawn out of the secondary side of the transformer. With the rated load being 0.250 kVA, our current draw will be approximately that of which will put the transformer at its fully rated kVA capacity. Exceeding that kVA rating will cause the voltage to start to drop or dip. So if we went up to 325 or 350, the lamps drawing too much current will cause the voltage to start to diminish or decrease from what we're expecting, which is that 120 volt range. You might see something as far as 115 or lower. This could impact the equipment performance. Sometimes, I don't know if you've ever experienced this, but if you're using an air compressor out of the garage and you're too far away from the main service, sometimes the air compressor will appear to not work or turn off, kicking out on low voltage. Once we decide to parallel the transformer, a couple of things need to be taken close attention to. You will want to make sure that those transformers have the same kVA rating, they're of the same class, and that they have of the same voltage ratings on the primary and secondary windings. By connecting 2 lamps, the same 2 lamps, 350 watts or higher, and having these transformers put in parallel, we've increased the amount of available kVA rating for the transformer bank. We still have the isolation that's required for a control transformer circuit, but we will now have enough voltage to power both loads. When I mentioned the paralleling of transformers, I also mentioned doing a polarity test. 2 instances where you will need to do that in this semester is 1 when you parallel single phase transformers, or when you get ready to close a delta. Thank you for watching, and I hope this helps.